Welcome to the fourth video in the series. This is on arithmetic sequences and series. You should have the notes in front of you. I gave you a copy of the shell of these notes so you don't have to write all this stuff down. An arithmetic sequence is very linear. In other words, a sequence might look like 1 and add 3 and get 4, add 3 and get 7, add 3 and get 10, and so on and so on and so on. So starting with 1, adding 3 each time makes this arithmetic. Each one of these terms has a difference, a common difference between them, and the common difference is d. And if you'll notice that if you graph these individual points, this is a discrete graph, not continuous. But if you made it continuous, you would see that it has a line that goes through it, and that the slope of this line is up 3 over 1, up 3 over 1, up 3 over 1. So the slope is actually the common difference. So you can see that on this particular one, d is equal to 3, and that is the slope of a line. To find the common difference of an arithmetic sequence, sometimes it's very obvious. Looking at the first one, you can see that you're adding 3 each time, and that's pretty easy. But if you take one term and subtract from it the previous term, the difference of the two is the common difference, which is 3. So for instance, they can go, this one is an increasing, this is a decreasing arithmetic sequence. This one is also decreasing. So when it's decreasing, I'm not adding each time, I'm adding a negative or subtracting. So on this one would be negative 5. On this one you can see that I have 1/2 minus 1 is negative 1/2. So the common difference here is negative 1/2. So if you take one term and subtract the previous term from it, you can do that on any arithmetic sequence. It will always be the same number. It has to be the same number between each one or it's not arithmetic. All right, if we have an arithmetic sequence, something very simple like this, 1, 3, 5, 7, where the common difference is we're going to start with 1 and we're going to add 2 each time. So the difference is that, and a sub 1 is equal to 1. Then can we derive a formula to find any term in an arithmetic sequence, no matter where it starts or how many terms it has in it? This one has an infinite number of terms, so this could go on forever. So let's start off with a sub 1. Let's say a sub 1 is equal to a sub 1 plus 0. So that would be the first term. So 1 is equal to 1 plus 0. 1 equals 1 plus 0, right? A sub 2, and the second term in this is 3, is the first term, which is 1, plus the common difference, which is 2. So in other words, I said the second term, which is 3, is equal to the first term plus the common difference, and we can see that that's true. Okay, the third term is equal to the first term plus what? Well, the third term is 5, right? And it's going to be equal to 1 plus 4, or 2 times the common difference. 2 times the common difference. All right, so this is times plus 4. Another way to write that, though, would be, I'm going to change colors real quick, a sub 3 is equal to a sub 1 plus 2 times the difference, like this. Okay, so a sub 4 then, a sub 4, or the fourth term, 7, is equal to 1 plus 6. Well, let's look at 6. The common difference is 2. This would be 2 times 3. So a sub 4 is a sub 1 plus the common difference, d, times 3. The one above it was a sub 1 is 2 times the common difference, right? All right, so one thing I want you to notice here is that these numbers here are related. They're not the same, but they are related. So d is the common difference. On this one, this would have been d times 1, right? So if I wanted to find a sub n, I would still use the first term plus something times the common difference. And what we're going to find is it will be 1 less than the term number. And this is the formula to find any term. So in this sequence, if I wanted to find the 20th term, right, I would start with the first term, and then I would do 20 minus 1, it would be 19 times the common difference. So a sub 20 would be the first term, which is 1, plus 19 times 2. 19 times 2 is 38, plus 1 is 39. And that is the 20th term. It's not the sum of the terms, but it is the 20th term. So to find the sum of an arithmetic sequence, what you're going to do is you're going to, say for instance, I want to find the nth partial sum. So I want to find the sum of the first 20. I would say S sub 20 is equal to 20, that's the term number, first plus last, and divide that by 2. So you're taking the first number and the last number, you're dividing it by 2, you're taking, dividing all of the pieces, and then you're multiplying it by the number of terms. Now, the nth term, this is the formula that we just derived. A sub 1, the nth term of an arithmetic sequence also can have this form, where you take d times the nth term, but then add to it the a sub 0 term. So c is the same thing as a sub 0, or the term before a sub 1. So for instance, if I have this sequence, that one we've been using, right, where this is a sub 1, this is a sub 2, a sub 3, etc., then the term before that, a sub 0, would just be the same. This is plus 2, plus 2. Well, then how would you get to here? This is also plus 2. So you would say that a sub 0 is going to be a sub 1 minus d. And so a sub 0, c is the same thing as a sub 0. This would actually be negative 1 because you would subtract 2 to get to here. So here is another way to write this, and sometimes it's easier to write it with this when you need the rule. We're going to do some examples on the next page. These are pretty simple. Find the common difference. I'm just going to take 9 minus 5 and get 4. It's getting bigger, so d is equal to 4. Find the common difference for the arithmetic sequence for this formula. Well, on this one we said before that a sub n was equal to the difference times n plus a sub 0. So the common difference for this is going to be 6. A sub 1, a sub 0 would be equal to 3. The slope, notice that the slope is going to be the common difference. So a sub 0 is equal to 3. A sub 1, if you put a 1 in for n, is going to be 9. All right, to find the 10th term of this sequence, I would use the formula a sub n is equal to a sub 1 plus n minus 1 times the common difference. So a sub 10 is equal to the first term plus 10 minus 1 times the common difference. And right here we are adding 2 to each one, so this is a 2. So 3 plus 9 times 2 is 18 equals 21. So a sub 10 is 21. Number 4 says find a sub 7. So a sub 7 is equal to the first term, which is 3x, plus n minus 1, so 7 minus 1, times the common difference. Well, the common difference is negative x. This is an algebra problem. So I have a sub 7 is equal to 3x, 6 minus 6x, and so a sub 7 is going to be negative 3x. Number 6 says find a formula for the sequence 1, 3, 5, 7. So we want a formula for the sequence. So we're going to look at, we know that the first term, a sub 1, is 1. We know that the common difference is 2. Think about this, but what is a sub 0? A sub 0 would be the term before this, which would be 1 minus 2, which is negative 1. So a sub 0 is negative 1. So to find the nth term, I would say a sub n equals, the slope is the same as the common difference, n, minus 1. And that's one way to do it. Another way to do this is to use the formula a sub n equals a sub 1 plus n minus 1 times d, and fill in what you know. So a sub n is equal to the first term plus n minus 1 times 2. All right, so then when I work this out, I've got 1 plus 2n minus 2, which guess what is 2n minus 1. Same thing. Find the 25th term of this sequence. The 25th term, a sub 25, is equal to the first term, which is negative 7, plus 25 minus 1 times the common difference. Now, it starts out negative, so you have to be careful. This is actually increasing. So this is going to be negative 4 minus a negative 7 plus. So this is 3. The common difference is 3. So I have 24 times 3 minus 7, which equals 65. Now, if you wrote that another way, if you wrote a sub n is equal to the slope, which was 3n, and then I need the term before that, so that would have been negative 10 minus 10. If I put in 25 for that, I get 3 times 25 minus 10, which is the same thing, 65. All right, number 8 says find the sum of the first 12 positive even integers. Okay, so positive even integers, the first even integer is 2, the next even one is 4, 6, 8, and so on, and so on, and so on. So I want s sub 12. I want the sum. S sub 12 is equal to n over 2 times the first plus the last. So let's put in what we know. We know s sub 12 is 12 over 2. I know a sub 1 is 2, but I don't know the 12th term. I don't know what a sub 12 is. So over here, I'm going to find a sub 12. A sub 12 is the first term plus 11 times the common difference, which is 2. So the 12th term is 22 plus 2, which is 24. All right, so I'm going to take this number, 24, and I'm going to put it in here and solve. So I now have s sub 12 is equal to 6 times 26, which is equal to 156. You might run across a problem that looks like this. Insert 3 arithmetic means between 7 and 23. And I put the note here on here. An arithmetic mean is the term between any two terms of an arithmetic sequence. It is simply the average or the mean of the given terms. All right, so what that looks like just in actuality is I'm going to write 7, that's my first term, 1, 2, 3 terms, and then 23. Okay, so that means then that I have a sub 1 is 7, and a sub 5 is 23. So what I need is I need to know what the common difference is. I don't know what that is, but I do know that there are 5 terms. So n is 5, right? A sub 5, a sub 1. And so I know that a sub 5 is equal to a sub 1 plus 5 minus 1 times d. I put in what I know. A sub 5 is 23. A sub 1 is 7, and solve for d. So 23 minus 7 is 16. So d is equal to 16 divided by 4, which is 4. So now I know what d is. So now that I know what d is, I can do 7 plus 4 and get 11, plus 4 and get 15, plus 4 and get 19, and then it better be plus 4, should be 23. The 11, 15, and 19 are the 3 arithmetic means between 7 and 23. Okay, this last one here that I want to work is find the number of terms in this sequence. All right, so let's analyze what they've given us. We know the first term is 7. We know the last term, whatever that is 55. We know that the common difference is 3 because it goes up by 3 each time, but we do not know what n is. Okay? We do, however, know that n has to be an integer because n is the number of terms. So we don't have we have an a sub 1, a sub 2, a sub 3 term. We have 1, 2, 3 terms. We don't have 3.8 terms. We have just a whole number. So we need to remember that. All right, so I'm going to use this formula because this has everything I need in it. A sub 1, or a sub n equals a sub 1 plus n minus 1 times d. And then I'm going to substitute in what I know. I know a sub n is 55. A sub 1 is 7. I don't know what n is, but I know that d is 3. And then I'm going to solve it algebraically. Sorry, that's a plus. So 55 minus 7 is 48. Minus 7 equals 3n minus 3. I'm going to add the 3. And n, I don't know why I put x, but n is equal to 17. So there are 17 terms in that sequence. N is 17. It had to come out to be a whole number. Here's a problem that I would like for you to work in your notebook. This is an arithmetic sequence. Write out everything you know, including the sequence, and find the sum of all the rows in the theater. And I will see you in class.